Greetings everyone from different part of the world. I also see some of the participants online from Canada and US, and it's middle of night and another session. It will be early morning for them, but it's great that uh, everyone from different part of the world they value this event. So thank you so much for it, everyone. As today we had 9 technical presentations and also keynote speeches, and it was very interesting, and we're receiving some good feedback also. I think this workshop is generating quite good, I would say, discussion around this topic related to drought, flood, and water resources management. So today is our second day, and it's a session 3 that would focus on vulnerability mapping and risk analysis of sand and dust storms. So if you see one by one, we are taking different topics, and in the afternoon we have another session that will talk about earth observation and environmental modeling for flood and water resources management in the context of global climate change. So we are bringing quite distinctly, unique sessions, and experts have really got a very good topics on each of these sessions to present here. So be with us. Uh, so let's begin this session 3 on vulnerability mapping, risk analysis of sand and dust storm. And I requested Ms. Letizia Rosanna to be a moderator of this particular session. And there is a reason for that, because she is director of the Asia Pacific Center for Development for Disaster Information Management, right, based in Iran. If the event was in person, we would have probably be there with you and would have met you there. But anyway, COVID. Uh, and I think you are founder director also of this particular center, probably the first director. Yes. And within short time, if we look at your website, within short time, we can see some very landmark, unique publications. Already they are out from your center. So no one is better than you to handle this topic, being in Iran, being founder director of this center, and being very active contributor. So over to you, Letizia. Please take over. Thank you.
Thank you, Shirish, for this very kind words and this introduction. It is a pleasure to be here for this meeting, and I would like to thank the Office of Outer Space Affairs of the UN and the Space and Technology at the Iranian Space Agency at the moment of the Iranian Space Agency, with whom this session has been organized. It is a pleasure for UPDIM to be there. As you mentioned, UPDIM is a center that is based in Tehran, and it's and we deal with disaster risk information management. So it's very important for us to have this connection with the government of Iran and the various offices that are becoming interested in working with disaster risk reduction and management. So this workshop is really, really timely and important, and we look forward to discussing together, as you mentioned, space of drought, flood, and water resource management, which is very much the kind of issues that in UPDIM we do look into. The session today will particularly focus on vulnerability mapping and risk analysis of sand and dust storms. And sand and dust storms, as you mentioned, is a topic that we in UPDIM have been looking at. Even in 2018, UPDIM did a publication. And now more recently, we are publishing quite a landmark, actually, report on an overall risk assessment in the region, in the Asia Pacific region. So we're very much looking forward to this discussion with our partners today. Without further ado, I will give the floor to the first speaker. We do 3 speakers, and then we take a moment for Q&A. Of course, participants are always welcome to put in their questions in the chat box, and then we'll have 3 more speakers and more Q&A. So for the first topic, we're looking at geoinformatics for sand and dust storms, a vulnerability mapping and risk analysis procedure. And I would ask Dr. Ali Darvishi Burrani, from the Department of Remote Sensing and GIS in the Faculty of Geography in the University of Tehran. Dr. Ali Darvishi.
Hi. Can you hear me?
Yes, we can hear you.
Yeah, would you please let me to turn on my camera? It is impossible to turn it on.
Uh-huh.
I can't turn
I
it
don't
on.
control that either.
Okay, maybe somebody else. Can you do this to me
Actually,
too?
yeah, if you have been given presentation right, normally
Yeah,
camera can be turned out. There is
but I
nothing.
cannot. I click it
Oh,
several times, but I
sometimes
cannot
it's
do it.
technical glitch. Nevertheless, we hear you very clearly. So maybe we
Okay,
can.
okay. Let me to share my presentation actually. Let's stop. Okay. And can you see my presentation? Letizia, shall I start?
Yes, please go ahead. Ali,
Do you
go
see
ahead.
it?
Yes.
Okay, thank you.
Well. Thank you.
Okay. Thank you very much for this very interesting workshop. And I would like to express my thanks to you and USA and Iranian Space Agency for holding such an informative workshop and very important issues, drought, flood, and water resource management that all are linked to sand and dust storms. Actually, my presentation is about, as you can see here in the title of the first slide, is about the vulnerability mapping and risk analysis procedure that we already have done this project in Iran, and I'm going to talk about it. But before going to that, let me have a short explanation about the sand and dust storm. As you can see in this figure, in this slide, we are facing with three different kinds of, let's say, materials or with different sizes that they create dust storm or sand storm. Okay, by the way, the audience and the people in this room are familiar with sand and dust storm. I'm talking about a global phenomenon that, as you can see in these three figures in Tokyo, Tehran, and in Arizona in America, this is a global phenomenon. As you can see in the background, this phenomenon is a start from forest in let's say in Beijing to, let's say, in another side of the world to America. So we are facing a global challenge, and today I'm talking about the anthropogenic sand and dust storm. I'm not talking about the natural sand and dust storms with thousands of years background, for example, in some dry parts of the world in Africa or in Asia or Australia and other parts of the world. I'm specifically concentrate and focused on anthropogenic sand and dust storms that are related to drought, water resource management, flood, bad farming, climate change, global warming, land use, and land cover changes. Okay, so let me start with 3 or 4 examples of the anthropogenic sand and dust storm. The first one is go back to 1930 in the US, and the second one is go to 1970 in China, Central Asia in 1990, and 2000 in West Asia. You are familiar with this, and if you I just put these clues that if you search in Google, you will find a lot of information and documents regarding these 4 anthropogenic sand and dust storms that has been created by humankind. By the way, my colleagues and my friends, we are living in the time that 4 of 8 top challenges of the world are related to sand and dust storm. As you maybe you just Google it and write that what are the top challenges of the world, of the globe, you will be faced with with this list of eight issues that 4 of them, climate change, desertification, air pollution, and global health, are directly linked to sand and dust storm. Because of that, this session is specifically allocated to sand and dust storm. It's a very important issue that especially in Asia and Pacific. By the way, I'm going to talk about the geoinformatic applications as a robust tool for sand and dust storm studies. I will shortly explain about the source mapping and about the particle impacts analysis on vegetation, and finally vulnerability mapping and risk analysis. In one of our projects that we already, as you can see here in this part, we investigated the sources of dust using a satellite imagery of Landsat 5, 7, and 8 from 1984 to 20. And as you can see here, the rate of water area reduction is related to the amount of dust. As you can see here, the AOD or dust particle in the atmosphere are very closely related to the reduction of water level. The results of this project was about this map that, as you can see here, we have discriminated two different types of dust sources of arid water bodies origin, as you can see here in the Mesopotamia and the Tigris and Euphrates basin, this yellow colored dots showing the types of dust that has been created in relation to the water decreasing trends during last, let's say, 40 years. You will find the results of this project in this published paper in Aeolian Research, Water Body Changes in Tigris and Euphrates. The second thing is about the impacts, how we can use the geoinformatics to knowing the impacts of sand and dust. So in this our experiments, we created, based on our experiments in Ahwaz and in another parts of the southwest of Iran, we created in a greenhouse different concentrations of dust, and we put the leaves under the tensions of different concentration of dust, and we measured them, and finally we put them under the spectroscopy and measuring the leaf characteristics of these under tension plants in regarding different concentrations of dust. As you can see here, different concentrations of dust from 0 to 1000 microgram per cubic meter, different behaviors in compared to the fresh leaves. The results of this project also has been published in this International Journal of Applied Earth Observation and Geoinformatics. Okay, I'm going to talk about the vulnerability. The last part of my talk is about how we can use geoinformatics. Let's say geoinformatics is remote sensing, GIS, GPS, and all other related topics that can provide spatial data for specific analysis. It is a project funded by UNCCD and will be published very soon. As you can see here, we have the main drivers of sand and dust stored here. And after that, we should know about the natural and anthropogenic causes of sand and dust stored. After that, you have to know which aspect or which domains of a society must be considered for vulnerability mapping. Human health, socioeconomy, environment, and agroecosystem are four main domains of a society that can be impacted by sand and dust storm in order to make a vulnerability mapping. Okay, but how we can do this? We think about it and we said, okay, let's see which kind of data can be as indicator of these four domains. And we put these indicators mainly about, let's say, more than 80% of these indicators that can be used for vulnerability mapping are come from remote sensing, GIS, etc., as a maps, as a report, etc., as a satellite imagery, etc. So we put these indicators in three main components of vulnerability: adaptive capacity, exposure, and sensitivity. Okay, as you can see here, four main domains of sand and dust storm impacts are in health, with different aspects of health: community health, medical health, mental health, and also about socioeconomy, agroecosystem, and environment. These have main subcategories you will find in the UNCCD compendium. It was a project funded by UNCCD and we carried it on. Another project that we have done, and this is under review and will be published very soon, is about which kind of diseases are related to which kind of dust in the world. For example, in Sahara Desert, in Australia, in Asia, in Middle East, etc. We did a huge literature review about the diseases and specific that can be specifically related to sand and dust storm, and it will be published very soon. By the way, we said we want to start from health domains of sand and dust storm and how we can make a vulnerability map. As you know, Ahvaz is one of the most polluted cities of the world because of sand and dust storm. It's located in southwest of Iran in this region. And we find a relationship between dust suspension times and the number of dusty days in the city. And after that, we developed and we implemented the methodology that has been used and developed by UNCCD for making a vulnerability mapping. As I said to you, a vulnerability mapping has three main components: exposure, sensitivity, and adaptive capacity. Most of these parameters, as you can see, wind speed, dust sources, PM2.5, LST, land use, etc., came from remote sensing. Of course, we have another source of data that was not from remote sensing. We get this data from another sources that was available. And finally, using some GIS techniques, we use this formula to make different risk levels of sand and dust storm. As you can see here, we have the vulnerability classes in different risk levels. Very low risk levels, different scenarios we implemented for Ahvaz city with different, as you can see here, the vulnerability classes from red to green. And finally, we said, okay, we use this GIS and remote sensing data. We follow this procedure. And finally, we came to such a map and we said, this scenario is the best. How we can evaluate it, how we can say this is a good result. Because, you know, this vulnerability map could be a base for resource allocation, for treatments, for funding, etc. And we collected about 3,000 hospitalized people in dust events from the viewpoint of three main diseases that was detected in as on hospital records: respiratory, skin, and cardiovascular disease. And we collected all this information during 1 year of more than 20 dust events, and we analyzed this data and we said, oh, very good. We have done a very good, can see here, and you can see the concentrations of hospitalized people are almost adjustable to our results. And it was very good for us. And we said that this technique can be implemented to another places just to know the vulnerability to sand and dust storm from the viewpoint of health issues. This also has been published in this journal, Environmental Pollution, as a vulnerability mapping and risk analysis to sand and dust storm in Ahvaz. People that has interest can find these published papers. And thank you very much for listening for me. Letizia? And I'm ready to answer any question if there is.
Thank you so much, Ali. This was super interesting and really thorough, in-depth work that I know we looked at very carefully when we in Uptim did our own work on this. I would suggest that if there are questions for Ali, we can pick them up later. Dr. Boulani, sorry, I go with first names, as I have the pleasure of having met Dr. Ali Boulani before. But so we'll take a Q&A later and we go to the next presentation. Thank you very much for sticking also to the time. And for the next speaker, the agenda says myself, but I would, with your permission, ask my colleague, Amin Shamsedini, who is the author really of the study that he's going to present, to do the talking. We would like to share with you and how to understand to contribute to a broader understanding of climate-related disaster risk through information management. And we look at the case of sand and dust storms in Asia and the Pacific. It is a work that has taken up a lot of our time and effort in Uptim in the last months. And so precisely with the view in a way with, sorry, this was the timer that I had set for myself in case, or to manage the earlier presentation. So Amin, I give you the floor, and then we can look at the questions if there are any at the end of the third presentation. Thank you so much.
Thank you,
Amin,
Letizia.
are you there?
Yeah, thank you, Letizia. Let me share my screen.
Yeah, we see it already.
Okay.
You would like to share your own screen, or I can help display?
Yeah, I already shared my screen. Okay, so I think I can handle it. Thank you. Good morning, good evening, everybody. My name is Amin Shamseddini, and I'm working as a program officer at AppTeam. Today, I would like to explain how AppTeam use the remote sensing data to have a deeper understanding of the negative impact of sand and dust storm in a large geographic area in various socio-economic sectors. Earlier, we have a speech by Dr. Ali Darvishi, and it was a very nice focus on the Ahvaz. In this presentation, we have a broader, actually, a geographic area, Asia Pacific. As Ali mentioned, remote sensing is very important, have a very important role here. Without accessing these techniques and data, this kind of assessment, if not impossible, but would be very difficult and costly. The overall aim of this project is to increase our understanding of the impact of this phenomenon with the view of facilitating conversation at the regional level toward increasing resilience. The analysis we did for this assessment underscored that there is still significant gap between the research and knowledge at the technical level and its application at the policy and investment level. Let me start with the sectors we considered in this assessment, as well as the overall methodology and conceptual framework of the assessment. In this study, various sectors were considered, including agriculture, energy, particularly on the solar power plants, environments, mostly on the glaciers, health, cities, and transport, mostly the aviation. And to do the assessment, we defined the concept of a risk, as you can see in the right of the screen. We defined hazard with different threshold and concept based on the way and mechanism that they impact each and all sectors. For vulnerability, we have the concept of exposure and sensitivity. Also, we consider the resilience of these sectors that's dealing with sand and dust storms. I will explain them briefly today, but the report would be available after its launch in the DRR committee of ESCAP later this month, where actually it's initially requested AppTeam by member state to develop such assessment. In the report, you will see the full explanation and details. Now a quick look at the data we used for the assessment and data sources, which were mostly available online and free. For hazard, actually, we use the MERA2 reanalysis dataset in its NetCDF format. It's a great source of data developed by NASA based on remote sensing, satellite images, models, and observed data. It's actually a huge data set for example, for more than 60 terabytes for only the ground level. For the period we used, it was a challenge for us to play with such amount of data. So we reached out to Tokyo University. They kindly provide the technical support and their supercomputer to handle this amount of data. The data coverage for this database is from 1980s to date, and it contains various indicators, including the dust concentration, dry and wet dust deposition, etc., for the time step of 1 hour. You can see the data from sectors in blue box. I would like to particularly mention about the agriculture and environment sector, which again, we study. I mean, this study benefited from the remote sensing generated data. We use the land cover map, which was produced basically from the MODIS data. In the next few slides, I'm hovering through some of the sectors we assessed and some findings. In this slide, you can see the population at risk of sand and dust storm. For this sector hazard layer, calculated based on the WHO air pollution guideline and defined as the average number of days annually when the dust concentration level exceeds 50 microgram per cubic meter. So with the data from Meraturi analysis, we generated the hazard map and overlaid it with other risk components. For the exposure, we consider the population exposed to sand and dust storm, and for sensitivity, we use the subnational human development index and the population of children and elderly people in each pixel area. We also try to include gender sensitivity, but considering that this analysis was done in a regional scale, the difference was negligible. For resilience, we use the indicator of public and private expenditure on health sector. As you can see, the highest number of people located in some level of dust concentration area are in India, Pakistan, and the Islamic Republic of Iran and China. When we normalize the numbers based on the total population of each country, this graph, Turkmenistan, Pakistan, Uzbekistan shows the highest level of exposure. This kind of analysis can help us for reducing the risk by developing the impact-based forecasting. We can use them for new human settlements and some other application. The other way actually to see the health, we use the same hazard layer for cities. This graphic shows the exposure of cities in Asia Pacific to sand and dust storm. We consider dust exposure in cities with a population higher than 300,000. The graph shows that this is, in the right side, you can see the population in y-axis and the number of dusty days in x-axis. And you can see, you can see the cities of Ahvaz, as Ali also mentioned, have a very high dust. Also, Hyderabad and Multan in Pakistan, they are exposed to dangerous level of dust concentration for more than 2/3 of a year, actually in 2019. This one shows the exposure and impact of sand and dust storm on energy sector, particularly, as I mentioned, solar power plants. For this analysis, indicators we used for the hazard layer was the level of dust deposition, which covers the solar panels and reduce the efficiency of generator. And again, these indicators come from the Meraturi. For this one, we assume these panels are cleaning actually on a monthly basis. And based on this assumption, we calculated the monthly cumulative dust deposition. The map on the left shows the location of the power plant and level of the average dust deposition. And the map on the right is the average amount of energy produced by solar power plant and the percentage of loss due to sand and dust storms. Another sector is the aviation. We considered two main mechanisms that sand and dust storm impact this sector. The first is the risk of flight cancellation and delay due to low visibility caused by sand and dust storm in airports. Due to that, we converted the dust concentration indicator of Meraturi at the ground level to the visibility level, and then based on the average number of hours per year that the level of visibility dropped below 1,000 meters, we generated hazard map, you can see here. And since the airport have different navigation instruments, the resilience of each of them to sand and dust storm are obviously different. So we categorize the navigation instrument of each airport in 5 levels, from very high to very low. And very high resilience actually means they have quite advanced navigation system, and less depending on the visibility. You can see here. And finally, by aggregating these values, we come up with the risk map for flight cancellation and delay. You can see at the far right corner. This one shows the another aspect of risk to aviation sector, the risk of erosion in aircraft engines due to dust. To do this, since most of flight times are spent in the cruise elevation and not at the ground level, for the hazard layer, we use the level of dust concentration in cruise elevation and use the flight distance and duration, which make the level of exposure to exposure of engine to dust particles. The highest values you can see in a purple color. Here you can see the exposure of agricultural land to dust deposition. To generate this map, for the hazard we use the MERA2 dust deposition, and find the exposure we use the land cover map, which generated based on MODIS data. We overlaid the average dust deposition and analyzed the area in which dust cover agri-land. At the right side of your screen, you can see the exposure of agricultural lands to average dust deposition in countries of Asia Pacific. As you can see, in Turkmenistan, more than 70% of agri-land are exposed. This one shows the glaciers in Asia and Pacific and their exposure to sand and dust storm. This map also used the dust deposition of MERA2 and MODIS to identify the glaciers in the region. The most noticeable feature of this map is the large exposure of glaciers, glacier ice to some level of dust deposition in Himalaya Hindu Kush and also Tibetan Plateau, that's widely known as the third pole because of the large amount of freshwater reservoir, and it basically provides fresh water to 1.3 billion people in that basins. Also, you can see the list of the basins that are exposed to some level of dust. Okay, now I'm going to summarize some findings. Actually, you can find the details in the last chapter of the report once it's released. Just to mention, more than 80% of entire population in Islamic Republic of Iran, Pakistan, Tajikistan, Turkmenistan, and Uzbekistan are exposed to medium to high level of poor air quality. And cities in the southern part of Asia have the highest exposure to sand and dust storm, where nearly 60 million people experienced more than 170 dusty days in 2019. A large area of farmland are affected by dust deposition in Asia Pacific, particularly on Central Asian countries, where we know we have a lot of salt in the material of this dust storm, and it boosts the negative impact. Also considerable impact on the generation of electricity by solar power plant. It's not only solar. We know that other part of the energy system will affect it, but in this study we focus only on solar power plant. Exposure of aircraft engine also is another issue that's in the path in the southern and central part of Asia are mostly affected. In the Arabian Peninsula, Pakistan, India, and China are mostly affected. Also, risk of flight delay and cancellation due to low visibility are greatest in the airport in Central Asia, southern part of the Islamic Republic of Iran, and the border between Pakistan and India, and northern part of China. From the long-term perspective, I already mentioned about the importance of the glaciers in Asia and how it can impact it. I mean, the hydrologic regime can impact it by sand and dust storm. It have also some negative affect side effects, like we experience different pattern for drought, for flood. So it's makes some water security issue, agriculture, poverty. You can see the details in the report. We also have a look at the projection of the sand and dust storm in the region, and we expect to have increased sand and dust storm in due to the extreme drought condition in part of Western Australia, southeastern Turkey, Iran, and Afghanistan. At last but not least, this assessment couldn't have happened without enormous support from our partners. You can see the list of a few here. The details will be available in the acknowledgement of the report once it's released. And at the end, I would like to share the table of content of the upcoming report. The report is organized into 5 chapters: an introduction of on sand and dust storm in Asia Pacific. It's linked to SDGs and intergovernmental mandates. The second chapter is on the methodology, in which we explain the risk framework and how to measure risk in various sectors. The third chapter, basically the core chapter, is sectoral risk analysis. Chapter 4 is on the projection of sand and dust storm in the region and also economic loss. And the last chapter is about the findings of this study, as well as suggested next steps for coordinated regional action on sand and dust storm. We'll send the invitation of the launch of the report later this week, and you are very welcome to join if you are interested to hear more details. Thank you.
Thank you very much, Amin, for the presentation. And as I mentioned before, we'll save the questions for until the third presentation, which we are about to listen to now. I would like to invite Dr. Ali Abukar, the Managing Director of Agriwatch BV in Enschede. I don't know how to say this place in the Netherlands, so maybe you can tell us. And Dr. Ali will talk to us about geospatial-based information for agriculture drought monitoring in the sandy soil of Eastern Netherlands. So if Dr. Ali is online, I would like to invite him to turn on his microphone and camera. And
thank you. Yes, I'm online. I hope you can hear me.
Yes.
Can you hear me?
Yes.
Yes,
yeah.
Sir. Could you please share? Okay. Yeah. Could you please change the slides because I don't have access.
Emma, do you have slides?
Yuan, next slide.
Hello?
Yeah. Emma, can you move the slide and check if it's working?
Yes.
Okay. Okay. Come to the first one. Mr. Ali seems his image is frozen. I think he lost his connection. Let's see. I think we lost him, Lizia.
Okay, let's see. I thought he was asking to move the slides.
Yes.
Oh, there he is. There he is. He's coming back in. He's coming back in. I couldn't see his image was frozen in my screen. Apologies.
No, I can see his video is frozen, and so slides are working well. I asked my colleague to
All
check
right,
it.
so we're about to resume now. I can see that Dr. Ali Abukar is coming back into the conversation. Sir, can you hear us and see us?
Yes, can you hear me now?
Yes, we can hear
Okay.
you. The presentation is up on the screen.
I don't know what happened. Sorry, now I connected through my laptop because I disconnected from the cell phone. Sorry, I'm currently in Tehran, and yeah, I'm not used to with this internet. And good morning, good afternoon, and yeah, it's a great pleasure to be here and share with you some of our experience about agricultural drought monitoring in the Netherlands. We are also interested in the application of remote sensing as well as local sensing data collected for precision agriculture under new climate conditions such as drought. to, of course, advise farmers. That's our main goal, to help them, to empower them. And for the monitoring of the drought effects, which are mainly we are interested in, most of the data will be coming from remote sensing data, including satellite, drone, as well as ground data, and they are processed to various levels of relevant parameters. Could you please go to the next slides? Yeah, Agriwatch was founded by a group of universities, by a group of alumni from ITC University of Twente, to serve those farmers, and our main focus is to empower farmers, and of course we acknowledge the increasingly challenging situations that farmers have to deal with regarding global warming and of course new governmental policies. There are rules and regulations which are dynamic and changing and create challenging situations also for farmers. And also we see the importance of agriculture to end world hunger in a sustainable manner. And that's why we are interested and to support farmers by using geospatial solutions to combine platforms, using rule-based or expert systems in a participatory approach to engage with farmers. Could you please change the slide? Next one, please. Thank you. Our business operation in the framework of precision agriculture or smart farming starts at the farm level, and then goes to the field level, which at the scale of hectares, and then the homogeneous management units, which is normally called management zones, at the square meter level. And then where detailed information is needed at the plant level is mainly where we use terrestrial sensors, as well as sensors on board of drones, where we have the gap with the satellite data. And our, as I mentioned, our emphasis is in the monitoring of the droughts. In this project, in the eastern part of the Netherlands, where we are dealing with the sandy soil, and our focus also is on affordable remote sensing data to empower farmers, for example, to use light sensors as well as light drones for doing the drone data acquisition where and when needed, when there is a gap, because they are the best expert in their field and they are available 24 hours, 7 days a week, and then upload the data into the cloud where we process and also get their feedbacks on their management actions, and then provide them with the intermediate or the final results. And that is the main focus in this study. Could you please go to the next slide? Thank you. In this project, which is funded by the Dutch government, we are focusing the monitoring the agricultural droughts or economic in the eastern part of the Netherlands. And the goal of this project is the development of an agricultural management support system for a changing climate, with the emphasis on the effects of drought and water management. So here the main interest is to really provide the farmers or advisors with the reliable and current information on the extent of the drought affected area or crop, and to look for adaptive measures to deal with these losses, and then to also and for this, most of the data will be coming from the remote sensing data. Next one, please. The urgent needs of farmers in Netherlands, especially in the eastern part of the Netherlands, the region which is called famous is the Twente region. Is the rain or the water, especially during these climate change conditions. The likely reductions in effective rainfall and increase in temperature due to climate change, that is the main issue, especially in the spring and summer rainy drought conditions, where time and space change of the rain in the study area happens. As you can see from these maps, we see the continued potential of the precipitation surplus in millimeters, which shows the difference between the amount of precipitation and the calculated reference crop evaporation. And this difference is summed daily in the period from 1st April to the 30th of September, the growing period. And of course, as you can see, the negative numbers indicate a deficit, especially in these maps is for the year 2017, 18, 19, 2020, as well as this year up to yesterday, which I could download, and from the Netherlands Meteorological Organization. And as you can see in the red color, there is a minus 300 millimeters deficit during the growing season in the 2018, as well as in 2019 and 2020, especially in the eastern part of the Netherlands, the Twente region. Next one, please. Next slide, please. I hope I'm connected and you are hearing me. Yes, thank you.
Yes, yes, you are, and we can hear you very well.
Okay, okay. That is, these are the ground or terrestrial pictures showing the drought effects, and the farming situation in Netherlands in the past few decades been so standard and been doing so well, producing, as you know better than me, half of the world food. They are numbers second in terms of the export of the food and agricultural commodities. But when we look at the maize, especially in the past few years, we had the challenging situation, and the situation is not sustainable as it used to be, not especially under these new climate conditions. Especially the main issue is the less effective rainfall during the spring and summer period. The amount of rainfall, it has not changed and even maybe increased, but during the growing season, there is a challenging situation, especially with in the rain-fed, or dry farming situation. So the climate change is really a total game changer here, where the farmers cannot anymore cope, and they need support. And we would need to build adaptation strategies, linking local knowledge with the state of the art of satellite, Earth observation, drone, ground sensors, as well as the climate data. So next slide, please. Next one, please.
Changed. Did you see? Can you see?
I don't see the next slide myself. I'm not sure if you, okay, thank you very much. I see now the next slide. So what I'm trying to present in this slide with a few pictures and drone images are the drought effects. And the fundamental to understanding the effect of droughts here is the view from drone and ground, pictures. We expect significant differences. Even in this stage of growth, for example, we have high fraction of soil which is visible. For example, in this drone image in the middle, which is from 12 June last year, where we see the wheat effects at the early in the season in the maize plot. We see the effects of the droughts, the fungus, because, for example, in 2019 and 2020, in June, July, we didn't have any rain. And then in the months of and high temperature, and then in the months of August, from mid-August till end of August, we had lots of rain. The temperature increased, the humidity increased, and then we had this fungus, which was really a challenging situation for farmer, or lack of phosphate. Of course, there were enough nutrition in the soil, but because of the sandy soil or dry soil, the roots had difficulty to transport the nutrition from the soil to the plant. And these are the challenging situations where we need to engage with farmers. And also, as you see, this zipper or the cobs or the maize ears, which are empty situation. Could you please go to the next slide? In the next slide, if I'm trying to show the study area, our study area is located in the eastern part of the Netherlands. This is just one of our influential dairy farmers. We are working continuously with 5 farmers in Twente region, and these demo farms has with a combination of circumstances like soil variation, differences in groundwater levels, differences in management practices, and spatio-temporal distribution of drought effects at the local level is used for testing and experimentation. And of course, it can also help us to use geoinformatics techniques like the other presenter has mentioned, remote sensing, GIS, GPS, etc., to scale solutions to larger areas, as well as gain a better regional understanding of challenges and situations. Could you please go to next slide? In the next slide, I'm trying to give you a bit of ideas how we try to engage with farmers, how to involve them in this, in the, let's say, remote sensing image analysis and image processing, in order to provide them with practical and useful information. So through different source of medias and a sort of wiki knowledge portal, we try to for example, define the region of interest, the plots which are currently under, for example, maize growing, if we are focusing in maize crop and not on potatoes and grasslands. And then to have the parcel info where we can start with downloading the satellite data and look for where and when we need detailed information which is not provided by satellite data. Next one, please. In this slide, as you can see, we are focusing in maize plots for farmer 1 as a demo farm. Then the main questions or challenging question here for this farmer, or the extra information needed by this farmer, because they have already lots of information and knowledge. So we make use of those, but what is missing? And how much, for example, corn or glass replacement had to be purchased externally because of the drought effect, and where, when, and how did the shortage arises? And then show the expected, of course, drought damage. We provide them with map, images, links to the estimated losses in mass and quality, and of course to be linked to the provided images and maps and their feedbacks in a group of farmers where they can also learn from each other, and also in the background processing we can learn also with the information which can help us.
I cannot hear Dr. Abkar anymore. Hello? Shirish, can you hear, or is it only me who got disconnected?
No, we cannot hear. I think he has little unstable internet, looks like, because he's not in Netherlands, he's in Tehran, and we don't know his internet situation where he lives. So maybe couple of minutes and we can ask him to come back. He will connect and then.
Dear Shirish, hello everyone.
Yes.
I can hear you very well. I think Dr. Abkar has some technical problem issues.
It seems he reconnected just now. Dr. Akbar, I think you're there now. Or we can give him concluding words during discussion time towards the end.
Yes. Okay, so why don't we understand Dr. Abkar was towards the end of his presentation. Why don't we take a few questions now based on the first three presentations as per the order of the agenda, and then we go on to the other three presentations. Am I on track, Shirish?
Yeah, perfect. I think that's a good idea.
All right. So just then opening the floor for questions or clarifications on the first three presentations by Dr. Dervishi, my colleague Amin Shamsuddini, and this last one from Dr. Abkar, whom I hope will join us back soon into the conversation. I see one hand up, and I saw also one question in the chat. So we take Marwan Kodami right now as a question, and then we take the question in the chat line. So Marwan Kodami, the floor is yours.
Yeah, thank you very much for the presentation of Dr. Ali and Dr. Amin. My question, what is the possibility of fixing the sand dune? There is the possibility of spreading asphalt on the sand dune to fix the sand dune. As Saudi Arabia prepared this experiment and spreading asphalt over the sand dune to fix the sand dune and to reduce the impact of the sand dunes and dust storm in the Middle East and other areas. Also, what about plantation of jojoba? You know, jojoba is fixing the sand dune, and we can get fertilizing for sheep and for animals, and also for getting the oil of the jojoba plant with the cost of 1 liter, $10,000 US, and it is possibility to fix the sand dune and to, as you mentioned, for applying or adopting sustainable development. And thank you very much.
Thank you for your question. I'm not sure whom to address it to in terms of fixing the dunes, but I see that Dr. Abkar has joined us in the meantime. Perhaps I can ask him, Marwan, with your permission, we'll let Dr. Abkar finish his presentation. Can you hear us, see us? Are you back with us?
Yes, I'm back. Can you hear me?
Yes.
Okay. So, Yeah, thank you. Please just say on this one, it doesn't matter. So here, what we are trying to say is that regarding the water management issue, where possible to retain water is very important, and especially to harvest the rainwater in the 20 region, in the drainage, in the channels, in reservoirs, in the pillow type of water tank. Then to reuse it in case there is not enough rain during the growing season, like 2018, 19, and 2020. But this year so far been good. Next one, please. Yeah, next slide, please.
Actually, your slides are changed immediately, baby. You are getting it late.
Okay. This is just to show for example, we use also the 2-meter resolution SuperView satellite data, and which the boundary which is shown on this different color composition is the ground truth map of the flattened maize or the destroyed maize caused by climate change effects such as drought. And you see the different tones of color. And then we use this as a ground truth for developing the method for information extraction from satellite data. Next one, please. In the next one, also, we are using different indices like water index from also Sentinel data, the digital elevation model, where you see in the top right image, in this 3-4 hectares parcel, there is about 2 meters of height difference, which is very important in the sandy soil, which is about the depth of the sandy soil in some cases like 3 meters. So please note that, and then in case there is even rain in the growing season, there is a runoff, and the water would run to the lower part, and then we had this lack of phosphate or transportation of nutrition. Next one, please. We also use the Sentinel-2 data. Next one, please. Yeah. Yes. So here is we generated, for example, different biophysical parameters like leaf area index, canopy chlorophyll 2 content for 2019 and 2020. The top is 2019 images, and the bottom is or the maps are 2020. And this CCC of 2019 shows areas of low CCC, leading to a correct management decision to leave out an area with low CCC for maize in 2020, the bottom part. You see the bottom part is left out by farmers, and this is really based on the advice which we provided to farmers. And if we
I think we may have lost Dr. Abkar again. And this was actually a very interesting part of the presentation in terms of how to use the space applications and the technology and the observation data on managing the crop production. I guess we go back to the question, and I check with Ali and Ali Dervishi and Amin if they would like to address the question that Marwan had asked on the managing of the dunes. Do either one of you want to come in, Amin or Ali Dervishi?
Letizia, about the sand dune movement, I think we have not done much in our study. So probably someone from UNCCD, probably that's focusing on the source area, would be in a better position to respond.
Okay, and Ali, did you want to?
Yeah, actually, I want to add a point regarding this, the dunes fixation. As maybe everybody in this room knows, that dune fixation is a tough issue, and it has a long history, and different types of mulching, petrol mulch, chemical mulch, and biological mulch has been used in different parts of Iran, Iraq, Russia, China, everywhere. And the new issue that I know, I'm aware of that, I have been in China, as I met you in China. I went to Gobi Desert, and I also in Taklamakan in China, and I saw there is a new technology named soilization. They use some kinds of material to convert the dunes into an agriculture soil. And if you have the water resources available, the dunes can be agriculture fields. I saw this new technology in China, and the Deputy of Science and Technology of Iran is following this story, and they are trying to bring this technology from China to Iran. And the scientist that asked this Marwan, I think, this question, if he has some interest in this issue, please contact me and I will directly send him the documents regarding this issue. Thank you.
Okay, thank you. That was helpful. I see one question on the chat, that was there from before, from Talbot Brooks, sharing actually a concern that they've noticed in studies around the US, in the US Sunbelt cities, noting that the incidence rate of asthma and similar respiratory diseases is significantly higher among children who attend school closer to major highways. And I think we have found similar points ourselves in our research, but it says also that they attribute this effect to the dust generated stirred by increasing commutes to and from work due to urbanization and the proximity to the highways. But the question was whether our panelists have found similar findings and using the work to work with high resolution data to support this information. So Amin and Ali, I know you both can answer this. Amin, do you want to go first?
Sorry, Letizia, it was some trouble in my connection. Can you repeat the question? Sorry.
Okay, I'll go to Ali to see if he heard me, and then you can read it in the chat, read it in the meeting chat, so that I don't repeat it. Ali, did you hear me?
Yeah. I heard you. Actually, I didn't understand what high resolution data means. The first thing. And if the person that asked question let us what it does mean after that, because as you know, there are 5 types of dust, let's say industrial dust, mineral dust, mineralogical dust, agriculture dust, marshland dust. Different types of dust have different characteristics related to health issues. You know, for example, we have some types of dust from marshlands in Iraq with different impacts than dust from agricultural fields from southern part of Iran. They have different impacts. You know, so we should first know which kind of dust we are talking about. The second one is what it does mean higher resolution data.
Okay, I guess we can perhaps take this bilaterally. But clearly there is interest in comparing notes about how far can we go with high resolution data in understanding the impact that sand and dust storms have, especially on health.
Sorry, Letizia, I just want to add one point about the high resolution things. Actually, if about temporal resolution, we already have a good temporal resolution of 1 hour that we use from Meraturi analysis. And about the spatial resolution, for regional scale, it was kind of okay, but for a smaller scale and for some sectors, for example, for land transportation, we face some issue because due to the resolution of about 0.5 degree by 0.6 degree, we missed lots of local dust that may impact the visibility in local scale. So yeah, definitely higher resolution will help us to catch this level of dust as well. Thank you.
All right. Okay, thank you. I see that Dr. Abkar is back. We are a bit late on the schedule already, so perhaps with your permission, I would go to the next presentation. Unless, do you want to take a few minutes, just 2-3 minutes, please, to wrap up your presentation, Dr. Abkar?
Yeah, thank you very much. Sorry for the technical issues, and if you share maybe from a slide, I don't know where to start, maybe with the 22nd, just to show some terrestrial photos and the challenging situations that we have, or the farmers have in our region. Yeah, these are just for example, these are the challenging situations where the farmers are confronted with: the zipper pattern, the poor kernel set in maize, the damaged cobs or kernels on exposed end of the year from 2019, 2020. Way too much damaged stress with the heat stress, with the drought stress, and also the dead, maize plant, and the background effects. These are the challenging situation. Just to wrap up, and also leaf rolling occurring in the sandy soil, but not in heavier textured soil. The sandy soil is very important parameters here. And if you please show the last slide, the conclusions and the recommendations. Just to mention that we try to combine different platforms such as satellite, drones, ground images, and tools for monitoring the occurrence of the drought. And the extended management model must address, for example, the following factors: the objective functions for farmers, which is the crop yield or the cost, to minimize the cost or increase the yield. And the methods that we have looked into is the soil improvement, like soil mulching, the soil preparation, the water management, like water retention, rainwater harvesting issues, the crop type, the planting, the weed control, which is very important, especially with the weed control. There is we have to differentiate between the LAI coming from the wheat as well as the maize plants, and to inverse the model to exclude the wheat LAI, the pest control. So the models that we use, for example, for crop yield forecasting, is the crop growth as a function of crop variety, planting time, soil moisture, temperature, humidity, weed competition, the pest stress, and these sort of things are very important parameters, and to use for the mapping of patches or zones of properties or practical management parameters for the detection of these homogeneous management zones, for example, for smart irrigation, which is affected by one or more stress factors. This is a sort of segment-based improvement of determining the relevant properties of land patches. And the model improvement in this case is very important by feedback on the effects of management actions as compared with the expected or predicted effect. Thank you very much, and sorry for the problem. And let me know if there is time for any questions or thank you very much.
Thank you. Your presentation was very interesting. I would invite, if there are questions, to maybe pop them into the chat line so that you can address it bilaterally. While you were temporarily gone, we addressed a couple of questions that came from other participants to the speakers. And given that we're a little behind the schedule, I would suggest that we move on to the first presentation of the second lot, as it were. And it's my great pleasure to invite Dr. Savi Serhat from the Atmospheric Science and Meteorological Research Center, ASMERC. And Dr. Sehat, she will talk about sand and dust storms risk assessment over West Asia. Saviz, I also know you personally. It's a great pleasure for me to introduce you. I would suggest you take the floor if you can hear us.
Thank you, Madam Chair. Can you hear me?
Good to see you.
Okay. Sorry, can I ask to share my my screen in order to have my presentation? Can you see my screen?
Not yet.
Okay. Unfortunately, I cannot find the button in order to share. Can you ask?
It's have you sent your slides to our colleague, Miss Emma Gao? She was requesting your slides.
Because I just asked because of some animation. I just wanted to show, but by the PowerPoint.
You can go up on the right side where you see a red button called Leave. On the left of that, there is an arrow. You click that, and then it will help you share the screen. On the right top, do you see the red button Leave with telephone?
See.
And then left side of that is a
or also next to the microphone, to the right of the microphone.
Between microphone and leave button, there is a up arrow. And if you click that, it enables you to share your screen. Then you have to choose the right window, or you can just choose. I think it's coming up.
Can you see it now?
Wait.
Yeah, can you see it? Okay, great.
Yes.
At the outset, I just wanted to.
Can you blow the presentation? Can you zoom it?
Yeah. Cool. At the outset, I just wanted to apologize because of my voice since I just got COVID-19 and sorry for the voice. As you may consider, I'm just going to talk about the SDS risk assessment over the Middle East. As you may consider, you all know about the dust cycle and associated processes that, we have got dust impacts on several fields such as ecosystems, meteorology and climate, as well as air quality and human health, and also aviation and ground transportation because of the low visibility, as well as agriculture and fishing, and also energy and industry. Dust can play an important role in in the energy budget through wet and dry deposition and also biochemical chemical actions. As you may consider, over the Middle East, there are several kinds of influencing factors on dust genesis. The main one of them that are in synoptic scale can be called prefrontal winds and also postfrontal winds, as well as larger scale trade winds and shamal winds. But also we have got some mesoscale dust storms, such as downslope winds, gap flow, convection, and inversion downburst storms that are really hard for the models, most especially regional models, to be captured. As you may consider, synoptic dust storm can play an important for dust genesis over the region, most especially during the winter. For example, these are the examples of the synoptic dust storm over the region, and as you may consider, this is the cirrus line, that is the type of cloud which most of the time are accompanied by pre and post frontal, let's say, dust storm. These are the MSG or metal sand second generation output. As you may consider, these are geostationary satellites that have got very rapid scan, and they are very useful for operational, most especially for the forecasters in several national meteorological and hydrological services over the world. As you may consider, this is one of the synoptic dust storms that is called postfrontal, you can see again those black cirrus clouds that are accompanied with postfrontal clouds, and these are one of the signs that use the forecasters in order to see us better and also nearcast them by the satellite. I have got another kind of, let's say, indicator in order to show the pre and post frontal, let's say, dust storm. You can see here the breaking of the wind that has been done because of the passing of the, let's say, the fronts. And these are, let's say, these are the calypso that are the leader pathfinder that are used for, let's say, identifying the thickness of the dust that are very useful in the region. Also, we have got summer shamal dust storm because of the convergent topography, most especially over the Tigris and Euphrates that starts from the high mountains over the northern part of the region to the flat parts which are over the Persian Gulf. And also we have got large scale trade winds that most of the time they happen over the north west of Africa, and you can see another example. For example, because of the high pressure, you can see a 10-0 pressure gradient that comes to 10.05, and this pressure gradient makes very huge dust storm. And also another kind, there are downslope winds. For example, as you may consider, Baudelaire has got the biggest, let's say, biggest dust storm over the globe, and it has got diurnal cycle. And also, we have got some mesoscale dust storm that is called Habub. Unfortunately, in 2016, we had one example in our country, and five people unfortunately died. Sorry, it was in 2014, and that was exactly the time that there was a steering committee for WMO sand and dust storm, and it helped them to just organize a project on this Habub that happened in Tehran in order to work on the model in order to have better clarification of such mesoscale dust storm. And captured by the model, and there are some types to improve the regional model. Synoptic dust storm can be captured by the regional model, but there are some, let's say, phenomena such as radiation or convection that because of the size of the to be captured by the regional models, and that's why it's very important to nearcast them by the use of satellite and also the data that is useful for, let's say, for nearcasting. As you may consider, dust storm can last from hours to days, and this is very tough situation, since for nearcasting a lot of high-tech resolution data are needed. The use of the afternoon constellation model, satellite such as Calypso, CloudSat, and Parasol can help in order to know better about the characteristics of dust, along with the data got from the Meteosat second generation, which are useful for the region. For example, also we have got the Indian Ocean Sat that has got 5 minutes rapid scan, and they are very useful for the forecasters. The composite EMATSAT RTV does use several algorithms. For example, the diffraction of IR20 minus IR10.8, and uses the dust reverse absorption in order to clarify between the dust and also the desert which is behind it, or also in order to clarify between the cirrus clouds over the dust and also the dust. Examples that our research center had got, the cooperation with WMO airborne dust, and we used this satellite data for several dust cases. This relates to a case in 2019 that happens in Sistan Basin. Another one is use of Calypso, and also the aerosol optical thickness data that was published in 2019 by WMO airborne dust. And also, this is the last one that has we just worked on a case that happened in Khuzestan province, and it was published in 2021 that we used Calypso in order to characterize the dust. As you may consider, the dust forecasting model do not take account dust resuspension, and there are some major challenges for modeling over West Asia. This is another example of MSG, and you can see by this arrow, this is actually this is the Manjil gap that is very convergent topography that is in micro scale, and these are the micro scale convergent topography that are located in our region most of the time are missed by the regional model, and it affects the sensitivity of the outline of the region. We can point to the anthropogenic influencing and forcing. This is the thing that happened to Lake Urumia, or the one that is happened to the Aral Sea, as you may consider during the 1960s, the Siriamu River were rechanneled for crop cultivation, and the Aral Sea diminished, increasing dust storm, and these are the results. And another factor that is, makes uncertainty over the region is the lack of actually dust mineralogical composition because of the limitation of the laboratories over the region, and that's why it makes studying it with more challenge. And this is one of the projects that I told you before for Habub in Tehran, that is called the cold down draft. And in some minutes, we have got rise in humidity, rise in pressure, high wind speed, and drop in temperature. With the help of Ministry of Industry, Mine and Train Geological Survey, these the field observation was just introduced to the model with the team of Serbia and Dr. Ana Vukovic, and then the model output was improved, and it is now under the publishment. And these are the Calypso outputs, and also the let's say some satellite outputs for, let's say, products for cloud properties and stuff like that. As you may consider, we have got the lack of remote sensing, a ground-based observation in our region, and that's why the calibration of the model according to UNEP and WMO report on the current needs and challenges over this region. It is said for many times that the satellites cannot be calibrated well because of the lack of these ground in situ measurements. As you may consider, in order to let's say have a better clarification of risk, we have to know about the hazards and vulnerability, as well as the property. In this research, which was the joint project with Department of Environment and University of Yaz and several other universities, Atmospheric Science and Meteorological Research Center just used the visibility data from synoptic stations over the region, and you may consider the very risky places by the color that are shown here in red. And this is the area of our study. We just at the first part we did this for Iran, and then we broaden our area over the Middle East, and you can see these are all the 3-hour interval synoptic station data that are related to the visibility in order to have better clarification of the dust behavior over the region. And these are the aerosol optical thickness properties for different modalities, as you may consider, because of the let's say canalization of wind, most especially in Besser part of Iran over Iraq, and let's say that comes to Saudi Arabia. We have got Jamal winds as well as gap winds over Sistan Basin, and these are the the dust flux output that shows the the hottest spot over the region. These hottest spots were considered for risk assessment. The thing that we did for this risk assessment is that we just based on the risk parameter according to visibility and winds that we had done for a 10-year study, we could find actually the risk map that you can see, different, let's say, categorization of it over the region. On the next step, we just try to get and use the global data such as the population distribution vulnerable to STS over the Middle East. As you may consider, these red dots are just refer to the the mega cities over the region. And then we just could get the farmland distribution map over the Middle East. The green one are the agricultural, and the let's say the pink one on the non-agricultural lands over the region, as well as the residence distribution map over the Middle East, and also the main road distribution map over the Middle East, as well as the airport distribution map over the Middle East. Then we just work on the health risk analysis over the Middle East. Sorry, we just did it for in annual and also in seasonal scale. But since this let's say this study hasn't been published, I just brought some examples of the season summer for you, as you may consider. For example, in Baghdad or Tehran or Mashhad, or the main cities in Saudi Arabia, you can see the red dots that show the health risk analysis over the region. And this is the map of the farm section risk analysis over the Middle East. As you may consider, the color dark orange shows the very high risk of agriculture that is affected by sand and dust storm during summer, and you can see its distribution over the region. And these are the examples of let's say the seasonal distribution, let's say agricultural risk analysis over the region. And this is the example of the residence distribution risk analysis over the Middle East. This is this is based on the the residence distribution over the region, and you can see again in those parts that we have got, so let's say the main cities, so we have got again the very high risk of residence distribution. And also you can see the road transportation risk analysis over the region, as you may consider Iran, Saudi Arabia, Iraq, and also Pakistan and Afghanistan, that have got more role in the main road and also the byway road. They are more affected by the sand and dust storm. For example, Turkey also has got a very actually considerable property in the manner of road transportation, but because of the let's say the influencing factors of dust genesis that I mentioned at beginning of my speech, so Turkey is less affected. And this is the air transportation risk analysis. You may consider the average high, very high, or very low portion of the risk analysis by the the value of the circles that are shown here, as we may consider over Saudi Arabia and best parts of Iran, as well as Afghanistan and Pakistan, that we have got another gap in these parts. They are more affected. Thank you very much.
Thank you very much. It was a super interesting presentation. As mentioned, we'll save the questions for after the three. So we go straight to the next one. Again, Marwan, one second, I get it properly. Marwan Kudmani from Remote Sensing and Space Science Office, and he'll discuss with us space technology applications for drought, flood, water resources management, and early warning systems in Syria. So, Marwan, if you can hear us, yes, the floor is yours.
Thank you very much. Yeah. Yes, it's my honor to thank Dr. Simonta Dibibo, Karim Barabadi, and Murtaza Bari, and Shirij Ravan, Yong Jao, Alice Borded, Lydia Rosan for organizing this workshop. Yes, my presentation is based on technology application for drought, flood, water resources management, and early warning system. Yes, next, please. Next slide. Yes, the content, introduction, examples of drought in Syria, examples of flood in Syria, water resources management in Syria, early warning system in Syria, recommendation. Next, please. Yes, as you know, space technology can play important roles in the reduction of disasters. The use of such technologies can be particularly useful in the risk assessment, mitigation, preparedness phases of disaster management. Next, please. You know, the time is very short. Yes, you know, thousands of satellites are roaming in the space for monitoring drought, floods, and many disasters in the space. Next, please. You know, all of the satellites monitoring all disasters, dust storm, forest fire, drought, hurricane, you know, many things. Next, please. Yes, next. During the past 40 days, natural hazards as dust storm, severe storm, and tropical cyclones, drought, flood, forest fires, oil spills have caused major loss of human lives and livelihood, the destruction of economic and social infrastructure, as well as environmental damage. Economic losses have increased almost 10 times. Next, please. 2020, 389 disasters were recorded, resulting in 15,000 deaths, affecting 98 million people, and economic losses estimated 171 billion worldwide. Next, please. This paper shows examples of drought, flood, water resources management, and early warning system. Yes, next, please. Examples of drought in Syria. We are exposed to many drought in Syria with assessment of current state of desertification, analysis of land degradation process, selection of basic indicators of desertification, mapping of degraded land and other related natural resources, evaluating the impact of land use change, and implementing rehabilitation measures. Next, please. You can see the effect of forest fires, increase of surface temperature, drought, decreasing soil moisture, hot wave, you know, sand storms, sand evaporation, you know, many things affect on drought in any country. Yes, next, please. Syria has exposed to many droughts in the and the flood in the last century, caused major losses of human lives and food production. We had in 1991 drought, also in 1996, also in 1999 to 1922, also drought, and also in 2008 and 2020 for this year. Next, please. We have a drought in Syria and Iraq in 2008. We can see a space image of Syria and Iraq. We can see the brown color mentioned that a large drought in this area. And many people immigrated from Syria to other stabilized city. Next, please. Also, we have a drought in Syria and Iraq in 2021, drought condition and affecting eastern Syria and northern Iraq since early 2021, especially in the governance of Al-Hasaka, Syria, and Ninawa in Iraq, after poor winter precipitation. Next, please. We have a global drought observation by Copernicus in 2021, and we can see this space image from Copernicus, and we can see the brown color in Syria and Iraq. Next, please. Also about examples of flood in Syria. Flood is an overflow of water that submerges land which is usually dry. It may occur due to an accumulated of rainwater and saturated ground in an aerial flood. Yes, please. Next. Here in 1930, we complain of many floods each year by flood in Barada River because the shallow of water in the river. What is the the best solution to reduce the flood? We can deepen the bed of the river for 5 meters or 10 meters and to reduce the impact of flood in this area. Next, please. Also, we had flood in Damascus in 2008. We can see the clouds coming from the west to Damascus, and with intensive rainfall, and we had big flood in Damascus city. Next, please. Also, we had flood in intensive rainfall in Damascus on May 8 in 2015. Also, the clouds coming from the northwest from Europe coming to Damascus, and with intensive rainfall, we had big flood in Damascus and with south victim in Damascus. Next, please. Also, we had intensive rainfall in Hasaka and Kamishli on March 30 and April 2 in 2020, and also with 7 victims, and we can see the floods in this area, and we can see the van in the flood of this area, and we can see the space image with intensive clouds over this area. Next, please. There is the Global Flood Awareness System, GLOVAS, by the Copernicus Emergency Management Service, CEMS. By Copernicus, we can get information about any flood in any place in the world. Next, please. What about water resources management in Syria? The concept of integrated water resources management has been around for some 60 years old. It was rediscovered by some in the 1990s. From the rainfall to surface water to groundwater to water use and to the treatment of sewage. Next, please. Many countries in the world complain of water problems, especially our region. Complaints of a great water shortage This probably increases greatly in the result of great increasing of the population, agricultural projects, and investment that will make additional pressure on water resources. Also, the water shortage or storage had begun complaining of pollution problems. Next, please. The new technologies of remote sensing, geographic information systems, and GPS and Landsat TM and European remote sensing satellites and GIS and geological, tectonic, hydrological, and hydrogeological study of the study region contributed as a method in exploration of groundwater in this region. Yeah, next, please. Yes, please. Next. By processing, analyzing of space images, compiling climatic maps of drainage, alignment, and main faults with their intensity and crossing, in addition to map of all the drilled wells, their discharge and existing springs in the study of each area, study of wet faults, and the end of summer through thermal bands in Landsat images, subsurface faults through radar images, cross the separated faults with their accurate coordinates by using GPS and carrying out geoelectrical sounding for perspective equation and analyzing the results curves and issue assurance of existing groundwater with their water table. Next, please. Yes, next. We had 85 many locations in Salamiyya, Suwaida, Drought, Latakia, Tartus, and Damascus cities. By using this methodology, we had drilled many of wells in the studied respective locations, and we had good results of water. Next, please. Yes, next, please. Also, we had studied the snow cover with the snowpack in Syria, monitoring the snow over the mountains in Lebanese and Syrian mountains and Suwaida mountains and coastal mountains. We can get by formula, we can get the snowpack of water we can get from this snow. Next, please. Also monitoring the Syrian lakes with is pollution, is Katina Lake and Asad Lake. We can see the pollution in these lakes and Asad Lake by monitoring by satellites. Next, please. Also exploration of groundwater in southern mountain of Syria by using Landsat and space images. We can see this space imaging, and with analyzing by ERDAS software, we can get lineaments map and drilling water and springs in Syria. With analyzing these maps, we can get perspective locations of groundwater. Then next, please. By using this advanced apparatus for resistivity methodology for exploration of groundwater, we can get perspective wells, and we can get drilling machine to have good results of good water by analyzing these images. Next, please. Also, we had good project for thermal survey over Syrian coastal and Lebanese coast for observation of submarine outflows and as anomalies by the supposed temperature. Next, please. And we had, subwater springs with fresh water along Syrian and Lebanese coast, and we have 58 springs with the fresh water in the sea, with the charge of 500 million cubic meter to 1,000 million cubic meter. Next, please.
Sorry, Marwan, do you have
Yes,
much
yeah.
longer? Because we are really running a bit out of time. Could
Yes,
I
next,
ask you
please.
to wrap it up in 2 more minutes, please?
Yeah, we will finish. Yeah, we will finish. Next, please. Also, water harvesting in Syria to combat drought in such area in Syria, and also treatment of sewage by private, treatment apparatus, and also with general treatment of sewage in the city with covered plant or opened plant. Next, please. And also early warning system in Syria. We are trying to apply this technology, next, please. Key component of early system are the data observation, data and information collection, hazard event detection, hazard warning system. Yes, next, please. Yes. Objective are early warning, also to better prepared to face challenges of the risk of long-term of sudden disaster by avoiding and reducing damage and loss, saving human lives, health, economic development, and cultural heritage, upgrading the quality of life. Next, please. Yes, by participating with the UN Spider in USA and participating with many space agencies, we can get data for early warning system. Also, next, please. Also, by participating with international share for space and major disasters, we can get more data from space to end user and early warning system. Next, please. And also use the remote sensing instrument on board of ISS, like muses and disease, hyperspectral images for early warning system, and also severe program. Yes, please. Next. And also using small satellites for early warning system. For each country can get early warning system. Next, please. And also using communications and navigation satellites for early warning systems. Next, please. Also, you can see GNSS, GPS communication, and to monitor with the lab as early warning system for disaster management. Next, please. And also using unmanned vehicles for early warning system. You can use drone for monitoring floods, drought, forest fires, many things of disasters. Next, please. Also using balloons for early warning system. When we fix any balloon with cameras working infrared and thermal infrared, we can get early warning system over any city. Next, please. And also using a robot for prediction and saving lives. Next, please.
Sorry, the connection is getting really garbled.
Recommendation, we can establish a national center for disaster management and early warning system, and integrated water resources management should be further promoted in the region. Next, please. Public awareness, also regional database of water resources and capacity building for transfer technology and for development. It is a fundamental component. Thank you very much. Next, please. Yeah. Thank you very much for your attention.
Letizia, looks like you are on mute.
No. Yes, I finished. Thank you very much,
Thank you,
Dr.
Marwan.
Shirish.
Thank you. Okay, and I think we can now go on to the next presentation. The end of your presentation, the connection was a bit garbled for me, so I hope it was better for our friends in other locations. I would now like to invite the third speaker, Kumars Alabakshi. Yes, you there from the Tehran University of Medical Science. He's going to talk to us about factors affecting early warning systems regarding the preparedness of the Iranian health system against dust storms. So, just checking if Mars is there. Can you see us, hear us? Manifest yourself if you can. Hello, can you see me and hear me? I'm beginning to wonder it's me, the pro.
Oh, maybe we can ask Fateme if this presenter is available. Did you contact him from Tehran University of Medical Sciences?
Otherwise, we can open for questions while you figure that out, because we are running also like a little bit.
I think we can open for question, and I will check with Fateme if this presenter is there.
Dr. Shirish, is he already as a participant or absent?
Emma, have you added him there?
Would you please check? Would you please check his link?
He's the
If I
presenter
can
now.
ask you, if you don't mind taking this offline, if you have a way to connect with each other. And I wanted to take a moment to thank Marwan Kudmani for the presentation. Some parts of it were a little bit garbled, but I hope you heard it clearly. And also open the floor if there are any questions from the other participants to him or to Dr. Sahat on the presentation that we heard before, so that we can address those while we wait for the last speaker, if we have. Otherwise, as we're really right on time, we could close now. So final show of hands for any question to Dr. Sehat and Kudmani. Okay, there don't seem to be. I don't see questions being asked. All right, and I think the last speaker may not be available right now. So perhaps with the permission of colleagues at the Iranian Space Agency and the UN Space Agency, I could maybe we could wrap this up. So, yeah, Shirish, should I wrap this up now?
Yeah, please. I think.
Yes, I think so. Yes.
Yeah, Fateme, please take over.
Okay. I would like to appreciate warmly the moderator, Ms. Dr. Rosano, and the speakers for their pleasant presentations. Obviously, the destructive and direct effects of sand and dust storm hazard on people's health have been the reason for dedicating this session to this problem, especially in the West Asia region. We encounter very much with this phenomena. In some months of the year, over 20 provinces in Iran may face kind of sand and dust storms. Remote sensing provides a good tool for monitoring, measuring, and identifying harvest points. Of course, the issue requires more interaction at the international level. especially with neighboring countries in the region, Turkey, Iraq, Afghanistan, and Iran, under the auspices of the United Nations, can reconsider the issue regionally and, of course, internationally. I think we should have one outbreak session, Dr. Shirish, and the next session will start at 14 o'clock local time in Tehran. See you all. Thank you.
Thank you. Could I also say a few words of thanks, if I may? I just would like to thank the Iranian Space Agency and the Ministry of Information Communication Technology, as well as the UN Office for Outer Space Affairs, for the kind invitation to UPDIM and myself personally to be part of this discussion and moderate this session. It's been extremely helpful and interesting. We learned a lot. We knew how important a space observation can be to better understand risk and to also, as we heard from the colleagues and the work that has been done in the Netherlands, to manage the risk. So we very much look forward to continue the conversation bilaterally with all the partners here and build on this great information and learn even more and do more work together. So thank you so very much.